Hello, in this video we want to explain to you about the setting of the digital load control. This device you see is a digital load control. In this video we want to explain to you how to set it up of this device for errors caused by load current. Suppose you have an electric motor and you want to detect load current distributions with this device. This device is used for a three-phase motor. This device detects a current error and disconnects the common circuit, and the power circuit is connected and doesn't allow the motor to work in the bad conditions. This device doesn't have a separate CT, and it has only three holes that you need the wires L1, L2, and L3 through these slots. To recognize the current information and cut the common circuit according to the settings you returned. The point is that it only has I1 and I2 CT, I3 CT here and here, and it only detects error that happen on L1 and L3 wires. Because I2 doesn't have a CT, it doesn't check the current of L2. And this device doesn't calculate L2 errors, and it only checks R and T, which is made in two models. The first is a 1 to 60 amps, and the other is a 0.5 to 50 amps. In this model, if you enter the settings, you will see the value of 1 to 60 amps from the overload section, that the range of 1 to 60 amperes can be seen, and the working accuracy of this device is 1 amp. In the other model, the range is 0.5 to 50 amps with the accuracy of 0.1 amps. This load control is designed with the microprocessor system. The follow control curve is displayed in this section here. It doesn't need a separate CT, and the maximum number of wires that can be passed through the slot is 25. This means that the wire up to size 25 can be passed through these grooves. The amount of passing current and errors can be displayed on this page, this screen. You can display the current errors against increase and decrease and asymmetric here. Well, now we want to explain to you how to set this digital load control. The first LED is OL, which if activate, indicated it indicated that the load control is more than the regulation current. For example, we have a motor that runs at the rate load of 10 amps. For example, we set it to 12, so that it is more than 12, that this relay will cut off the common circuit. So we enter the value of 12 in this part. You can see the value of 1 to 6 amps, but for this 10 amps motor, 12 amps is suitable. So enter the number 12 and press enter to save it. Press enter to save it. The second LED is a UL, which means under load, which measures the amount of the no load current. We can enter a number between 0 and 59 amperes. That range is a 1 amp less than the overload range. As you can see, you can enter the range of 0 from 0 to 59. 1 amps is less than the overload value. The third LED is a percent, which ranges from 7% to 100%. It shows the percentage of asymmetry between load controls. If you set this value to 77, the load current sensitivity will be very high. If the R and AT currents become more than 7% asymmetric, this load control cut off the command circuit. On average, this number is set at 14%. Of course, this value depends on the motor. For example, on the lease motor, we enter the number uh, 40. The fourth LED is on, which shows the connection delay for you. A number between 0 and 240 seconds can be returned. The maximum number of 4 minutes can be considered. That is, if a transit error occur and the current circuit of the fan is cut off, it will allow activation of the command after 4 minutes at most. Of course, if all the errors are fixed, in the beginning, the work doesn't allow a maximum of 4 minutes, and it is practically a period of time when the operator notice the error and cut off the command circuit completely. The next LED is off, which is a shutdown delay and is a number between 0 and to 10. For example, if a current fault occurs by the load control, uh, by the load, and we have set it to 5 seconds. If not resolved after 5 seconds, cut off the command circuit. There are transit errors on the load control, and we only want it to detect and fix prevent errors. The next LED is off UN. We want to increase the cutoff time. In a load mode, we use the settings, which considered separate time. Okay? Uh, we can by set between 5 and 10 seconds. For example, we select the overload on 2 seconds and we set the underload error to 8 seconds. So we set the LED of 2 seconds. So we set the LED off you to 8 seconds. So uh, here it's 2 seconds, and for LED off you is 8 seconds. Yeah, it's 2 seconds, it's 8 seconds. So if the load become asymmetric, or if we say we have excess current, it will cut off after 2 seconds. And if it becomes unloaded after 8 seconds, it will cut off the common circuit. When the normal LED is on, it shows the standby status of this device, and this device is error free and ready to work. The last LED is for a delay start, which can be entered between 0 and 120 seconds. You specify, let's say, 0 to 120. We specify how many seconds this electric motor takes to reach the rated current. This amount of time is different for each motor and is written on the motor nameplate. If you set this value low and don't enter the exit value, all the setting will give an error at first, because when the motor is started, it follow up to 5 times the rate current. This follow causes an error at the beginning of the work. For example, In this section, you enter the number of 20 seconds and specify that the first 20 seconds don't consider errors. After 20 seconds, when you reach the normal current, consider the current settings and if there is an error, disconnect the command circuit. Well, that is how to set up the digital load control. In the next video, I will explain how to wiring and errors. I hope you enjoy this video. If you have any question, ask in the comments section. In all the parts, but if you don't understand, let me know in the comments so that any video can be